I guess I should start the session now as 10 minutes have already passed. Um, Assalamu alaikum. This is Aisha Arif, and today's topic is environmental science and energy transition. As the subject environmental science is all about sustainability and ecosystem and the relations, so let's discuss the link between energy and environmental sciences today. Before we begin, please make sure to write down important point so it may help you during the assignment write-up. All right. First of all, let's discuss carbon cycle. The carbon cycle is most easily studied as two interconnected subcycles. One deals with the carbon exchange among living organisms, that is biological, and the other one deals with the long-term cycling of carbon through geologic process. Now, the reality is carbon exists in the air largely as carbon dioxide, as we all are aware, and this carbon dioxide dissolves in water or reacts with the water molecules either in the atmosphere or in the water bodies to produce bicarbonate. Now, the photosynthesis, the process by which the plants or some microorganism produce food for us, produce oxygen for us, like a bacteria, like plants, like algae, they use this carbon dioxide or the bicarbonate ions and convert it into organic molecules. The organic molecules made by the photosynthesizers are passed through the food chain. Obviously, these bicarbonate ions converted into organic molecules are actually the food that we eat, and they are passed through the food chains and cellular respiration, and this organic carbon is then converted back into the carbon dioxide gas. As you know that we eat the food and then we excrete it, and through the biological processes like fermentation, etc., this carbon that was produced is converted into, again, carbon dioxide. Another way, which actually is a long term storage of organic carbon, that occurs when the matter from the living organisms is buried deep underground. For example, when they die, or or we are aware, like living beings, and we are aware that living beings are made up of carbon. Like you have carbon in your body. Our basic molecule of our system is actually the carbon, right? So the living beings, when buried deep underground or sink to the bottom of the ocean, form sedimentary rocks, and we extract that carbon in the form of coal and fossil fuel. Volcanic activity or weathering of the rocks, and now human burning of fossil fuel has brought this stored carbon back into the carbon cycle. The geological pathway of the carbon cycle is a time consuming process. In fact, it actually takes millions of years ago for carbon to cycle through the geological pathway. As you see, the fossil fuel that we are using nowadays are actually the remnants of the carbon that is converted into coal or in various carbon products are actually the bodies of the plants and the dinosaurs that were present millions of years ago here. So this is how we utilize the carbon cycles in terms of energy. That is, we are made up of carbon. We utilize carbon in the atmosphere. We utilize the carbon conversion processes for to live, because it turned into the food, and it becomes part of the earth ultimately, and it converts into fossil fuel, and the cycle begins, or cycle again starts. Now, let's take a dive further into this topic of carbon and the use of carbon by all of us. We see the change in the climate patterns, right? The recent flood in Dubai is an example. Now, when we study the past trends, the climate change has always been the part of Earth's system. Just in the last 800,000 years, there have been 8 cycles of the ice age and warmer periods, like ice age and then warmer periods, then ice age and warmer periods, and so on. And the last ice age was about 11,000 something years ago, and this was detected by the carbon dating processes and other techniques. And the modern climate era began, like the era of human civilization. The changes occur due to these changes, that the alternate ice age, warmer period, ice age, warmer periods. These changes occurs actually due to very small amount of variation in Earth's orbit that change the amount of solar energy by that our planet receive. Actually, the rotation or the orbiting of the Earth change during the passage of time, and as a result, the amount of sunlight that our Earth receives changed. So that was the reason that these ice age and alternating ice age and warmer periods occurred like about 800,000 years ago. But what about the change at which the rate which the sun's energy is stored by the earth? That is what actually happening nowadays. Now, related to this concept is the term called Anthropocene. As you can see, Anthropocene is actually the unofficial unit of geological time used to describe the most recent period in the Earth history, where human activity started to have a significant impact on the planet's climate and ecosystem. As you can see on your screen, the carbon dioxide level has not increased more than a certain level till 100,000 years ago, and latest raise in the carbon dioxide level, as you can see, that in 1911, and then this rate raised in 1958, and then it is continuously increasing and increasing. There is no decrease after the industrial revolution. So this time period in which that the earth history or human activity uh, has started to have significant impact on the climate is actually Anthropocene, and this is the present time period, that nowadays we are living in this epoch of the time. So the current warming trend is different as compared to that was in previous millions of years ago, because it is the result of human activities. The production of atmospheric gases that have trapped more of the sun energy in the earth system. It is because of this that climate is changing, the carbon dioxide level is increasing. The production of energy has warmed the atmosphere, oceans, lands, and caused rapid changes in the atmosphere, oceans, biosphere, and everything. Now, as I already mentioned, that this term Anthropocene is quite recent. Otherwise, the era or epoch that we were living started about like 1100 years ago. That I already said, previously mentioned, that about 11,000 years ago, the last ice age ended. So after that, the new time period of the history, which is called Holocene, started. Now, Holocene started with the last glacial maximum, which was a time period where the Earth's continental ice sheets reached their maximum, and then the glaciers started to melt because of the warming of the Earth. And the glaciers that we see today that are now again melting, we hear about them all the time, are actually the remnants of that period. Now we are aware that most of the carbon dioxide comes from energy sources, right? Hence, it is essential to understand the energy trend. Throughout the history, non-renewables, renewables have been used alternatively, as you can see on the screens. Like about 200,000 BC, fire was used as a source of energy. Then solar power was used. Then coal came, and then first windmill was introduced. Then wind power became widespread. Then later on in 1690, coal again started being used, and it replaced the woods to gather the energy. And then geothermal power came. And latest in fossil fuel started in 1800s, obviously, when the industrial revolution started. And then at in late 1800s and 1900s, hydropower plants were produced, and then first nuclear power plant in USA was developed in 1951. And then in 58, first geothermal plant was introduced in the New Zealand. And then in 1973, the energy crisis, the petrodollar, etc., caused the people to think that they should not rely 100% or solely on the fossil fuel. So they started going back to the renewables again. And new technologies also developed like photovoltaics. And at present, we see there is a mixture of fossil fuel usage of fossil fuel like coal, gas, and etc. And the renewables like hydropower, like geothermal, and like solar cells, etc. We are using the mix of all these energies. Now, to take action to reduce emission, we need to understand and measure where they are sourced from or where they come from in the first place. Obviously, if we do not know that where we are getting all this carbon dioxide in the atmosphere, we would not be able to mitigate the effects of those, right? So scientists have developed three scopes to categorize different kinds of emissions a company or organization or industry creates in its own operation or in its wider value chain. First is scope 1, as you can see on your screens. It covers the emission from the sources that an organization or a business or a company owns or controls directly. For example, burning of fossil fuels of the vehicle. The scope 2 and 3 deals with the indirect emissions. Like scope 2 are the emissions include the emission that a company causes indirectly and come from where the energy it purchases and uses is produced. For example, the emission caused when generating the electricity that we use in our buildings would fall into these categories. It is indirect and indirect source of emission, obviously. And the scope 3 includes emission that are not produced by the company itself and are not result of the activities from the assets or owned or controlled by them, but they are those that it's indirectly responsible for the up and down its value chain. For example, when we buy, use, and dispose the product from a supplier, it's an example of the indirect emissions. Okay. There's a concept of another additional concept of scope 4 recently introduced in 2013, and it covers avoided emissions. It is actually the voluntary metric. It was devised by the World Resource Institute in 2013 and has since been used by many organizations. It involves any reduction in the emission that occurs outside of a product's life cycle or value chain, but as a result of the use of that product. For example, the energy saving battery in a phone, it reduces the electricity usage and therefore prevents emission from being generated compared with the traditional battery. The scope 4 deals with the that kind of emissions that are avoided by the users, not the industries but the users. The example is mobile phone batteries. And this scope 1, scope 2, scope 3 are related to the carbon footprint. What is that? Amount of carbon dioxide emissions associated with all the activities of a person or other entity. That could be an organization, could be business, could be an enterprise, could be anything. And this carbon footprint methodology is used by many organizations to control or to regulate their carbon dioxide emission. For example, we have we have the US Environmental Protection Agency, National Conservancy, and British Petroleum. They have their carbon footprint calculator. If you can search on their Google, if you can search on their websites, you will find the calculators that individuals can also use to determine their own carbon footprint in daily lives. You may be wondering if carbon footprint calculates our carbon footprint, like how much carbon dioxide we are emitting by utilizing the products or services, then what the term LCA or life cycle assessment do? Here's a major difference between the two. It's the carbon footprint consists of a single criteria, that is only greenhouse gas emission. What your product, what you are using, how you are using, uh, how much of a carbon dioxide you are releasing into the atmosphere. CF or carbon footprint is calculating only that. LCA or life cycle assessment, on the other hand, evaluates the potential impact of product on the environment, society, based on the physical flows of material and energy associated with it. That from the manufacturing to the death of that product, it calculates all of the impacts, not only the greenhouse gas emission, but all of the impact. So obviously, since carbon footprint consists of a single criteria, this method is faster and easier to interpret. On the other hand, the life cycle assessment is more in depth and requires a longer study and more work to interpret the results. Okay, now I didn't share the file, you guys. Now, IPCC, you might must have heard of this intergovernmental organization, United Nations panel. It's actually what United Nations body for assessing the science related to the climate change. And the functions of IPCC is assessment of scientific literature, that the all over the world the researchers are researching on the impacts of the climate change, or how to reduce them, how to mitigate them. They are assessing that scientific literature, and then communicating that scientific literature and their own findings to the global community, and creating global collaboration and engage the policymakers to combat the climate change. Now, they publish reports on their findings, which is actually a mass of huge data and knowledge, and how to extract valuable information from that report. I just shared an IPCC report in the WhatsApp group. You can see it later, or if you can download it early, you can see it now. So, since the IPCC reports are mass of huge data, obviously you cannot read or understand it immediately, right? You need to first open the report and get the idea of what the report is about. So it is quite a hassle to read their reports, because it is difficult, and the number of pages and number of data is too much. So let me tell you a little bit about how to read their report and how to use the IPCC report. This is just a journal page that I selected from the report. There's a screenshot of that report you can see on your screen. Now, the IPCC report, actually, obviously, it has so much data that you cannot read it at one time. So they also know that. So they have created a summary document for each section of the whole document. It's called Summary for Policymaker, or SPM. That was the page actually I took a screenshot of. First page is page 4 in the report that I have shared. Now, if you're looking for a specific topic or finding of your interest in any of these report, the SPM or the summary for policymaker is the best way to start, because it is actually just a summary of each and every findings they have published in the report. They have explained the report, and this section actually involves the summary of all the points. If you want any more information, you should check out what research the report cites, like given in the brackets in the text. They have also added the numbers in the bracket. There's actually the references of the studies that they have taken to assess those studies. Okay. And in the report, you will see bold lines here and there. These bold lines are actually the most significant findings of the report. Furthermore, they have also added the footnotes at the bottom of the page, uh, to say which of the report's chapters and section findings come from. You can see the 3.2, and in superscript there is a 14 on your screen. It's actually the 14 is actually the footnote, and this whole number or term 3.2 and in subsection 4 means that 3 is the chapter number, 2 is the section, and 14 is the number of the footnote that explains the where the data was taken from. Okay. And they use or express terms like low, very low, medium, high, or very high, depending on how much the evidence there for each statement. So you should consider, while reading the report, you should consider that how much is written in the bold letters and how much they are using like the words like high, low, very high, medium, etc., because they are actually uh, stressing those points in the report. Now, after you have read the summary for policymaker and you have chosen that you, for example, you want to check out the chapter 3 because it is of your interest, then you will go to the chapter 3 and you will follow all these directions. All these directions to read and understand the report, and then when you have absorbed all the information, take some time to reflect on its implication. How does the information in the report align with your existing knowledge or your beliefs? Are there any actions you can take based on this information, either personally or professionally, etc.? Then you need to share your knowledge with other people, other your colleagues or your family who are interested. Share your knowledge and discuss the findings in the findings of the report. Obviously, uh, sharing knowledge and perspectives can lead to a deeper understanding and could inspire some collective action. And then you need to apply that knowledge. Obviously, you are working for the mitigation of climate change and you are studying the impact of climate change. Obviously, you need to apply your understanding, your knowledge to do so, helping the community, helping your daily life or your work life, advocating the policy changes or adopting sustainable practices, renewable energy initiatives, supporting them or educating other people about them, etc., whatever you want to do. Now, let's discuss various types of renewable energy sources because, of course, what we are discussing is related to combating climate change through the transition in energy. Now, first one is photovoltaics and concentrated photovoltaics. Both of these use solar light as a source of energy, but there's a difference between two. The first one in the figure you can see on your screen is PV or a photovoltaic cell. And when the light shines on the photovoltaic PV or a solar cell, we call it in a general terms, the light may be reflected, absorbed, or passed through it, obviously. And the PV is made up of semiconductor material. The semi means that it can conduct electricity better than the insulator, but not as well as a conductor like metal. And this semiconductor material generates electrons. These electrons are actually the electricity. When a light falls on the PVs or photovoltaic semiconductor, it will knock out the electrons. These electrons would start to flow, obviously, from one place to another, creating holes in the previous place, and another electron would replace it, and the cycle would continue the flow of electron. And the flow of electron is, obviously, you know that it is current, and this current is then captured and transferred into the wire, thus generating direct current. And then this direct current is converted into alternate current using inverters, and it is then distributed to the power network. Now, the concentrated photovoltaics are slightly different. The concentrated photovoltaics actually concentrate the sunlight by using mirrors or lenses that have historically already being used. You might remember, or I don't know if you used to do that as a kid or not, but I used to do that. That most common experience during my childhood was that heating the paper using the mirror by focusing the sunlight using the mirror or the concave lens. I would burn the paper. This is a phenomena actually these concentrated photovoltaics are using. uh, a large area of the sunlight is focused. These cells actually, what they do, they the large area of the sunlight, it is focused onto the solar cell with the help of any optical device or a receiver. It would concentrate the light onto small area using the mirror or reflector, which would create high temperature at that particular point. The plant utilize this system, that is using this CPV or concentrated photovoltaic cell, consists of two parts. One that collects the solar energy, obviously, and it collects the solar energy and it is converted into heat, and the other one converts the heat energy into electricity. So the photovoltaic and solar concentrated photovoltaics, the difference is the photovoltaics are just capturing the sunlight, absorbing them or reflecting them, and then convert using the sunlight to drive the electron out of the atom, and using this electron as a source of electricity, while the concentrated photovoltaics are concentrating the solar energy into a typical point, and that and converting it to in heat, and this heat is used to drive electric generators. Next is wind energy. Wind energy system obviously transform the kinetic energy of the winds into mechanical energy or electric energy that can be harnessed for the users. The wind power plants use turbines, and the blades on the turbines are attached to the motor, which uses the motion of the blades created by the winds to create electricity. Now, there are two types of wind power plants: offshore winds and onshore winds. In the past, onshore wind turbines were most popular. That means that it's a very old technology. The earliest written reference to the wind machine was onshore wind turbine, and it dates from the 12th century. They were used for milling grains. Then windmill performance was improved between till 19th centuries, and in 1891, electricity from the wind speed or wind power was first time generated in Denmark. Now, the popularity. Okay, now then we have offshore wind turbines as well. These are relatively a new concept or a new technology, and it comes after 1930s. The idea first came on 1930, and in 1972 a professor at MIT University introduced the idea of large floating turbines to generate electricity, and in 1990 a company called Whirlwind constructed and installed the first offshore wind turbine at sea. This offshore wind turbine was located in Sweden, and it generated the power of 220 kilowatts. Now, the wind energy is, as you can judge from what I have already mentioned, that is a very old technology. So, with the passage of time, this technology lose interest, and then gain and the people again gain interest. This is the fact because of the changing fossil fuel prices. Now, wind energy is not very efficient as compared to the fossil fuel. So when the prices of the petrol and diesel raise, the interest of the investors and interest of the public in wind harvesting increase, and when the prices of the fossil fuel decrease, uh, the interest is lost. So up and down, the wind harvesting faces up and downs. Now, I have collected some of the opportunities or challenge, or you can say the pros and cons of onshore and offshore winds. I will not go into detail, but just gist of it is the onshore wind energy is actually a cheaper version of the wind harvestment, because obviously it is present onshore, it is present on the land, so installation cost is less, investment is less, etc. Whereas onshore wind power industry uh, has less efficiency, and they land cost could pose problem. On the other hand, offshore wind energy, obviously, uh, costly, it should be costly, and it has restricted access to supervisions and maintenance during operations because obviously it is away from the land. But it has advantages because of the robust wind speeds, because we know that in the sea, in the water bodies, wind is flowing fastly. But both of these technologies face similar problem, that is the noise pollution and uh, harm to the biodiversity, especially the birds. Next is hydroelectric power. Hydropower or hydroelectric power, I say, is the most famous or well liked renewable source of energy, and it generates power by using a dam or a diversion structured to alter the natural flow of a river or a water body. It also uses turbines and generator to convert the kinetic energy of the water into electricity, which is then fed into electric grid of power homes, businessmen's businesses, and industries. Now, with the passage of time, in order to harvest the maximum efficiency of hydropower plant, and also obviously whatever is man-made has harmful sides like ecosystem disruption, like extinction of species present in the water bodies, the fishes, many species of the fishes. So many the scientists have worked on advancement to mitigate the harmful impacts and to harvest the maximum efficiency. For instance, we have improved turbine design. The modern turbines are more streamlined, hence they can operate at wider range of the water flow, allowing for the better utilization of available water resources. Also, they can now change the speed of the hydropower generator depending on the conditions, depending on the adaptability, or how the river is flowing with different weather pattern or climatic condition. They have also underwater pumped storage hydroelectricity. This techniques allows for the storage of excess energy during times of low demand. By pumping, what it does, actually they pump water uphill to a reservoir, and when electricity demand is high, the stored water is released to generate the power. This stored water, when released downhill, would actually run the turbine and obviously would start the generator to produce electricity. They're also using remote sensing and remote sensing for the monitoring, using advanced sensor and monitoring system to detect for the early detection of the potential issues to improve the safety and reliability. And they have also using, or they have also prepared fish friendly hydropower. Actually, obviously they are using turbines, the blade of the turbine obviously disturb the flow of the fishes, right? So the new turbine design are actually fish friendly turbines. They aim to minimize the impact on aquatic ecosystem, and what they do is they reduce the pressure changes and provide safer passage for the fish. The fish passages in the upstream and downstream changes with the migration of the fish when dam impedes or stop their migration during a particular time period. Next is tidal energy, obviously a renewable source of energy powered by natural rise and fall of the ocean tides. And this too is run on the turbines. What they do is they place the turbine in the tidal stream, that is the flowing fast flowing water, and that is created tide. This fast flowing water runs the turbine, and then turbine in turn runs the generator to produce electricity. This can be done in barrages, just like in dams, and the water spill over spill over the turbines can also turn the turbines and hence power the generator to produce electricity. Now, a main drawback with tidal energy is what? Ecosystem disruption, obviously, because it is operating in the water. Also, this technology is still infant, it is still new, and the power produced, it's not very efficient. The power it is producing is very small, and there are some tidal power stations, like for example in South Korea, China, France, England, Canada. They also have potential to use this type of energy. USA is not using any tidal plant up to my knowledge. And there are also, especially in USA, there are legal concern about the underwater land ownership, because it's a common property, right? Seas are the common property. So the water bodies, and they have no right for to a particular owner, right? So investors try not to invest in the tidal energy investment. Next renewable source of energy is geothermal energy, and it uses the steam to produce electricity. The steams actually comes from the reservoirs of hot water that are present few miles or more below the Earth's surface. The steam rotates the turbine that activates a generator which produces electricity. And there are three types of geothermal energy plants. First is dry steam plants. They draw from the underground resources of the steam. The steam is piped directly from the underground wells to the power plant, and this steam is then directed onto a turbine or generator to produce electricity. Then we have a binary system. Binary system or binary cycle power, they operate on water at lower temperature for about like 107 degrees Celsius. Binary cycle plant use the heat from the water, from the geyser. We call it geyser, the natural hot water body present many miles below. So they are actually using the heat from the hot water to boil a working fluid. It working fluid is any organic compound, not any usually a low boiling point organic compound, and the working fluid is then vaporized because of this heated water, and it is converted into a heat exchanger, and it is used to turn the turbine to produce electricity. Then we have flash steam. Flash steam plants are most common ones, and they use geothermal reservoirs of water with temperatures greater than like about 182 degrees Celsius. This very hot water flows up through the wells in the ground under its own pressure. Obviously, it is very hot water, so it has a lot of pressure. So this hot water and pressurized water uh, moves with the help of its own pressure, and it flows upwards. The pressure decreases when it obviously it comes to the surface. The pressure would decrease, and some of the hot water boils into the steam. The steam is then separated from the water and used to power a turbine or generator. Now this too is being worked on, and many advancements are advanced technologies are being created for this particular source of energy. For example, they have drilling technology process that involves they have enhanced the drilling processes, and they what they do is inject water to create fractures, because the dry rocks are very difficult to break by a natural pressure or natural processes. So they inject water into the underground reservoir to create fractures and then stimulate the heat exchange. Then this company WeHeat introduced a closed cycle geothermal methodology. It employs a binary cycle approach where a secondary working fluid transfer heat from the geothermal reservoir to the power plant, just like we discussed in the binary steam. Binary cycle power plants also use a secondary fluid with a lower boiling point than water to capture the geothermal heat and drive the turbine. This system can operate at much lower temperatures. Now, the topic of discussion is how natural setting of a region aid or hinder the use of renewable energy resources. Anyone among you can answer me. That what do you think that natural setting of a region or a country or a place can aid or hinder the use of renewable energy sources? Mr. Abdul Tawab Afridi, can you explain your point of view in the topic of discussion, today's topic of discussion?
हेलो।
हेलो, अस्सलाम वालेकुम।
वालेकुम, आवाज़ आ रही?
जी, जी।
हाँ, ये नेचुरल रिसोर्स की हिसाब से यानी एनर्जी के हिसाब से बात हो रही है ना कि किस तरह हम रिवाइज कर सकते हैं।
जी के जो हम लोग अभी डिस्कस कर चुके हैं कि जो हमारे रिन्यूएबल्स रिसोर्सेज हैं, हम लोग उनको यूज कर रहे हैं नेचुरल चीजों से, लाइक सोलर को हम सनलाइट से ले रहे हैं, हाइड्रो पावर को हम डैम्स वगैरह बना रहे हैं। तो किसी एक रीजन या कंट्री का एक नेचुरल सेटिंग होता है ना, कि एक कंट्री डेजर्ट एरिया में होता है, एक कंट्री लाइक माउंटेनस एरिया में होता है। तो आई वाज आस्किंग कि क्या इसका इम्पैक्ट होगा to aid or hinder the use of renewable energy resources?
इसका यानी मेरे ख्याल से यानी अगर हम थर्मल यूज़ कर रहे हैं तो उसका इफ़ेक्ट यानी नेचुरल रिसोर्स जो है वो कार्बन डाइऑक्साइड ये वगैरह। अगर हम विंड वगैरह यूज़ कर रहे हैं तो उसका या सोलर यूज़ कर रहे हैं तो उसका इम्पैक्ट थोड़ा कम होगा, ये दूसरे की नस्बत।
ऑलराइट, थैंक यू। आई थिंक थोड़ा सा आपको क्वेश्चन शायद थोड़ा सा अंडरस्टैंडिंग थोड़ा सा हुआ है टफ। वो कोई बात नहीं। मिस्टर जुनेद फिदा, इफ यू आर अवेलेबल, कैन यू give out your point of view on the topic of discussion?
Assalamualaikum. Yes, sure.
Walaikum salam.
Like in Pakistan, if we see, we have glaciers, so the natural setting is there that to produce this hydropower energy. Also, we have the deserts where we can have this sun for almost full year. So this natural setting is there to produce solar energy as well. Wind is also there, and out of Pakistan, if we see, like in Middle East, we have a lot of this solar radiant energy available that can be utilized. Also, now they are doing the pilot project for the wind, and they are checking what will be the effect and how effective that could be to produce the energy. So they are looking into that particular spectrum as well. And in the north sea offshore, there is a lot of wind and storms. So that particular natural setting is there to produce wind energy. So that's it from my
Yes.
side.
Okay. Excellent. Excellent. Thank you. What Mr. Junaid Fida said is obviously right. Uh, for the solar to in order to use the solar energy, obviously you would need ample sunlight. Like for example, in Saudi Arab or in Arab countries, like you need to consider the cloud cover, altitude, atmospheric conditions, obviously, to get the maximum sunlight on that land. Then if you are trying to use the wind energy, then you need to study that are you going to build a wind energy plant in a coastal area, in a mountain passes? What is the local weather? Is the wind consistent or not? Similarly, for hydropower, regions with abundant rainfall, large river systems, geography, as like for the Kalabag Dam, three sides are mountains, obviously it would reduce the cost of building a dam. So you need to consider all these aspects. For geothermal energy, you need heat sources from the earth which are not present everywhere. These sources are only present where is high tectonic activities like volcanic eruptions, volcanic activity, hot springs, high seismic activities. Only there you would find these hot geysers for the geothermal energy. Similarly, tidal energy can only be used in the coastal region. So these are the effects of the natural settings uh, to aid or hinder the use of renewable resources. Now, at present, it has been estimated that about 52% of the total global carbon dioxide emission, 30% are from China, 15% are from USA, 7% from India, and 13% from the European countries, and the rest are from the rest of the world. It means that these states or these regions are creating a large amount of total carbon dioxide gas emissions. So, and our goal is to restrict the warming below 1.5 degrees centigrade to reduce the greenhouse gas emissions uh, about 45% by 2030. That is the goal of the carbon neutrality concept, which we have discussed in very previous classes. So, actions for controlling the anthropogenic or the man made carbon dioxide emissions are very important, are essential. So one of the step to control the carbon dioxide emission is CCS, that is carbon capture and storage. This concept was started or first introduced in 1977, and the objective is to decrease the release of carbon dioxide into the environment using three processes: capture, transport, and store or utilize the carbon dioxide with integrated technologies. But this process is extremely costly, so it is not used by every country. Now the process of CCS includes, as you can see in on your screen in the diagram, that we have different processes in which a different process or different ways that we can capture the carbon. For example, we have pre-combustion. This route uh, is used to decarbonize or capture the carbon of the fuel before the combustion, before the fuel is utilized. They capture the carbon from that carbon dioxide from that fuel by reacting it with air oxygen. Okay. Then there is another concept, post combustion. This route, carbon dioxide is captured from the flue gas. That is, after the burning of the fossil fuel, the NOx, nitrogen oxide, the sulfur oxide, the carbon monoxides, these gases are produced. That it's called flue gas. So the carbon is captured from the flue gas before its emission into the atmosphere, and this process takes high temperature, like at 120 degrees centigrade or 180 degrees centigrade, and is considered more feasible process for coal plants. Then we have chemical looping combustion, CLC. It can be it's actually the method which is cost effective comparative to all the other previously mentioned method. And it utilizes the metal oxide. These metal oxides of, for example, copper, iron, calcium, nickel, etc., they provide the oxygen needed for the combustion, and they deoxidize to metal in the fuel reactor and oxidizes the fuel to carbon dioxide and water vapors and capture this carbon dioxide. Then we have another uh, way or route, that is direct air carbon capture. This method of carbon dioxide captures, uh, it plays a very important role in emission reduction from decentralized and mobile units by the use of adsorbents. This actually process use adsorbent. For example, amino silica is an adsorbent that can capture up to 1 to 3 tons of carbon dioxide annually. So these adsorbents are used to capture the carbon dioxide. And since I already mentioned that about that total 52% of the total carbon dioxide emission, 30% of it is produced by China. So obviously it is creating a large amount of carbon dioxide. So it is also thinking or uh, trying to mitigate the effects of the carbon dioxide. They have also adopted this carbon capture and storage process in the form of CCUS, that is carbon capture, utilize, and storage. And this concept was introduced in 2005 in China, and currently 40 projects are involved in the capturing of carbon dioxide from the large point sources, like from the power generating plants, from the industrial facilities. Also, in September 2020, they also introduced a double carbon goal, which intends to achieve peak carbon by 2030 and to achieve carbon neutrality by 2060. There are also some technologies being researched by the developers to produce fuel from that carbon dioxide using catalyst. We can also use uh, biomass as a source of fuel instead of using fossil fuel. So biofuel actually is the energy harnessed from the organic matter, typically plant material or animal waste, and convert it into usable form of or fuel. Now, two types of fuels can be generated from the biomass or the plant material or animal waste. Biodiesel, which typically is formed by transesterification, is a process, actually a chemical conversion of triglycerides. These are the biomolecules into esters, like replacing the OH group with the esters group. This is called transesterification. Biodiesel is formed by this process from the vegetable oil or animal fats. And bioethanol, it is majorly made by fermenting sugars or starches from the crops like corn, sugarcane, or wheat. They are very rich in sugars. They are very rich in lignin and cellulose and starches. So these crops make bioethanol with the help of process fermentation. Fermentation involves obviously enzymatic reactions, and which metabolize the larger molecule into smaller molecule and convert into ethanol. So obviously we are using crops, we are using vegetables, we are using animal waste to create biofuels, and we are not going to use them as it is. We are not going to use the animal waste as it is as a source of bio fuel, but we are actually creating fuel, liquid fuel out of them, or in the form of gas. So we first need to deconstruct the crop or the animal waste or any plant material that we are trying to create biofuel with. So the deconstruction process can be done either with high temperature or with low temperature. The high temperature uh, deconstruction involve pyrolysis. It involves a very, very, very high temperature, like about 500 degrees centigrade to 700 degrees centigrade. We are heating the plants or animal waste or these things and converting them into vapor and gases. And this vapor and gas is then condensed to produce bio crude oil. Next, we can also use gasification. It's actually the same process, but the temperature here is even higher than 800 degrees centigrade or 700 degrees centigrade. And then we have hydrothermal liquefaction as well. This process is used when we are using algae as a feedstock instead of crops. We are using algae to produce the biofuel or bioethanol instead of crops. So, and this process, this hydrothermal liquefaction, operates at moderate temperature of 200 degrees centigrade to 350 degrees centigrade. Then we also have low temperature deconstruction. They use biological catalyst called enzymes, or we are using chemicals to break down the cellulose, lignins into smaller components. And after we get crude oil from all these processes or from one of this process, the next step is to upgrade that crude oil. And this upgrading can be done either biologically by using enzymes, fermentation process, and we can use catalyst. And this upgrading is done to remove the unwanted compound. For example, there might be some of the remnants of the lignin or the larger molecule present inside. So these processes, this upgrading is done to refine the biocrude oil. Now, just like any other source of energy, biofuel also have their drawbacks. Like, for example, the biofuel, the products are not entirely GHG free. Obviously, we are using the carbon inside the uh, this biofuel as a source of energy. So obviously, it's gonna release some of, although in smaller quantity, but it would release some of the carbon dioxide or carbon monoxide up to some extent. Furthermore, it is, as you can judge from the temperature range, that it is a highly expensive process. Furthermore, we have to consider the land availability for this process to take, for this process to continue. For example, we are using the crops to convert them into the fuel. So obviously, we would be using land. We would be cutting down the forest. We will creating habitat destruction, and obviously, the competition of the food with the fuel necessities would be either to emphasize on the food production or either to emphasize on the fuel production. It would be a disaster. So there are some backdraws to this process as well. Next, we have nuclear energy. Okay. Nuclear energy is a form of energy released from the nucleus, the core of the atoms made up of protons and neutrons. And this energy can be produced in two ways: either fission, where the nuclei of the atoms split into several parts, as you can see on your screen, the blue figure or image, and the fusion reaction, when the nuclei fuse together. The fusion reaction actually is the reaction that powers the stars and the sun, and it is highly, highly, highly uh, uh, energy intensive process. So this is the same process that occur in the hydrogen bomb. So it is difficult to control or change the process. Now, the main process that is being used to create energy from the nuclear energy is nuclear fission. Okay. Inside the nuclear, each time the reaction occurs, obviously when the nucleus is broken down, into its part, it would release energy in a form of heat and radiation, and this heat is converted into electricity in the nuclear power plant. The nuclear power plant has nuclear reactor, and their equipment contain and control the chain reaction. Obviously, when a nuclear reaction start, it needs to be controlled because it goes on and on and on. This is called chain reaction, that split into two, which is split into 3, 4, 5, 6, and so on. So it needs to contain. So the nuclear reactor has equipment to contain and control the chain reaction, as you see in your screens. And most commonly, the nuclear reactor is fueled by the uranium-235 isotopes. All right. Now, this isotope produce heat through the fission reaction, and the heat warms the reactor's cooling agent, which is mostly water, to produce steam. This steam is then channeled to spin the turbines, which activate the electric generator to create the low carbon electricity. Now, obviously, we are discussing the renewable sources of energy. So this type of energy too has backdraws. Like, for example, the nuclear waste. It produces, although it is not producing any greenhouse gas, it is not producing any solid waste, but it is producing nuclear waste. And the problem with nuclear waste is that if a person comes in contact, or even his clothes comes in contact with any radioactive material, the radiation would continue till half life of that radioactive material is reached, which could be hundreds of years. So the alpha, beta, gamma particles would continue to emit from that particular area or the cloth or a person even after his death. And this would continuously generate radiation around the environment, disturbing the not only the environment but also creating havoc in the bodies of the human beings or animals or the plants, etc. There was a Japan is famous for using nuclear energy as a source of their most reliable or their most producing energy from this nuclear energy. And in 2011, Fukushima Daiichi nuclear accident, after they suspended the operation of most of their nuclear power plant. But now with the carbon neutral goal of carbon neutrality, they have to reach the carbon neutrality by 2050. They're starting on it again. But the world is arguing, and the world is uh, showing concern over the waste of the nuclear plants. For example, last year when Japan dumped its nuclear waste into the sea, there was a huge uproar by the local people and by the United Nations, because it could damage the overall ecosystem of the ocean as well as us who will be eating those fishes and those using the oceans. Next, we have hydrogen energy. Now, hydrogen is present in abundance in our environment, like it is present in water. The formula of water is H2O, right? It is also present in the living form in the form of hydrocarbons, methane. Many hydrocarbons also have hydrogen in, like methane, fossil fuels also have hydrogen in it. So it has been estimated that the energy in 1 kilogram of hydrogen is equal to the energy present in 1 gallon of gasoline. So hydrogen has a very high energy density, so it can be used in a small quantity for very major applications. Now, hydrogen can be produced in many ways. First, I already said that is natural occurring, especially in areas with volcanic activities. But obviously, it is not present equally in each and every region. It is cheapest, but it is not present everywhere. Then we have obviously fossil fuel. We can create it from the coal gasification. We can create it from the GHG emission. We can create it from methane pyrolysis. But all of these ways generate greenhouse gases. Nuclear power plant, they have their own safety and operational risks. Obviously, you are using nuclear power plant and creating hydrogen from it. Hydrogen is highly explosive, so this would create risk, safety risk. The most green way of producing hydrogen is electrolysis of water using renewable sources. They are actually breaking the water using the electricity produced from the renewable sources like solar, hydro, or wind power. It is creating zero emissions, and it is portable as well. It has also problems just like any other way of producing. Hydrogen is very easy, difficult to contain. The storage of hydrogen is a difficult process, so it poses a problem. Now, when the energy or electricity has been produced, next step is distribution. Electric lines at high voltage, they transfer this electricity produced that we have discussed earlier, that we are using many renewable resources and we are now trying to distribute this energy to the people. So the electric lines at high voltage to a long distance and convert into a low voltage at the distributional station or a grid station. Now, there are two types of grid station. One is centralized, another is distributed. The centralized grid station is the traditional grid station. Power is generated at a large scale power plant and is located far from the population centers, and it transmits long distances through high voltage transmission line to reach the consumer. Then we have distributed grid stations as well. Here, the power generation is distributed across a network of smaller scale generators, including rooftop solar panels, wind turbines, energy storage system, and microgrids. Now, difference between both these grid stations, you can see on your screen that the central is obviously centrally located, and It transmit, as I already mentioned, transmit electricity over a long distance, but it negatively affects the environment because it is mostly using the non-renewable sources of energy, like from the coal power plant or from any other power plant. The distributed generation obviously is not location bound, and it can be installed anywhere in which the current energy source is present. And it is environment friendly because it mostly consists of energy from the solar plants or mostly from the solar plants or photovoltaics. Okay, now we have established that renewable energy plays a key role in the journey to net zero carbon emissions, helping to reduce the demand for the fossil fuel by providing cleaner source of energy. But as the world drives an increasing amount of its electricity from these renewable resources, there is a growing need for the technologies that can capture and store it, because renewable energy generation mainly relies on the naturally occurring factors. Like, for example, hydroelectric power is dependent on the river flows. So the river might not be flowing in some seasons, it might be flowing better in other seasons. Similarly, solar power plant cannot work at night, cannot work in the rainy season or a cloudy. Similar is the case with wind power. So that means that these resources are intermittent. They are not continuously providing the energy. So similarly, the demand for the energy is not constant either, that people may require more energy in some season or at some part of the year, and they require more energy at other part of the year, other times of the year. So there is a need to store uh, the energy produced from these renewable energy resources. So some of the ways to store this renewable energy, let's discuss them. First, we have pumped hydroelectricity energy storage. This is actually uh, this actually stores energy in a form of gravitational potential energy of water. When a demand is low, the surplus electricity from the grid is used to pump the water up on the elevated reservoir. Okay. When the demand increases, the water is released to flow down through the turbine to the lower reservoir, producing hydroelectric power for the grid as is do so, as you can see in the picture. Then we have electrochemical battery storage. Like, for example, we have lithium-ion batteries that we are using in our mobile phones and we are using in our laptops. We also have flow battery storage that consists of liquids. The lithium-ion battery has lithium and graphite as an cathode and anode, and the continuous transfer of charges between the two would create electricity. In comparison, the flow battery storage consists of two charged liquids which are separated by a membrane, and the surplus electric energy is used to reduce the liquid charge states of one and oxidize that of the other. And when we need the electricity, this process is reversed. You might have heard obviously of the charging and discharging. This is actually the redox process, the reduction of one part of the battery and oxidation of the other part of the battery. And when we require the energy, we are doing the reverse process of that, is discharging. Then we have thermal and phase transition energy storage, and it includes liquid to air transition energy storage. Uh, here, the surplus electricity is used to chill the air, or obviously chilling is making the air colder to the point that it liquefies. It is converted into liquid. This liquid is turned back into the gas by exposing it to the ambient or the normal air, which can be used to create the electricity or power the turbine. Then we have thermal sand batteries. This was first developed by the Finlands or Finnish researchers, and the sand battery. What it does actually, low grade sand is used, and it is charged up with, obviously when we get the surplus electricity, we are charging the sand battery, and this charge would heat up the sand of the battery. This sand would store the heat of up to around like 500 degrees centigrade, which can then warm homes in winters when energy is more expensive. Then we also have a mechanical energy storage system, like we have compressed air energy storage. Uh, it involves the process using surplus electricity to compress the air, which can be then decompressed and passed through the turbine to create electricity. Then gravity storage actually works by using the excess electrical energy from the grid to raise a mass, for example, a block of concrete, and it would generate the gravitational potential energy. When electrical energy is required, the mass is lowered, converting this potential energy into power through the electric generation. Then there is pumped storage, hydro heat electrical storage. Here, water is released from the higher elevation to the lower point to produce electricity. Then there is a flywheel energy storage. Uh, it also works on the principle of converting the kinetic energy of heavy, high velocity spinning wheels, the flywheels, and in converting this kinetic energy into the electrical energy. Then we have hydrogen electrolysis as well, like the fuel cells that are present to create the hydrogen. The fuel cells can be transported, can store the energy as well in the form of gas or liquid. As the gas, obviously hydrogen, as I already mentioned, that hydrogen storage require high pressure tanks. So it's a bit of a controversial, or I may say the difficult process of using the hydrogen electrolysis or hydrogen fuel cells. But it is being used. Now, why do we need to store the energy that we have produced, and why the grid management is important, is essential? As I already mentioned, that renewable energies are intermittent, right? So the river would not always flow the same way they are flowing in a particular season. The level might decrease or increase, sun would not always be available, etc. So the purpose of storing the electrical energy and the grid management is to store the energy. Obviously intermittent, the renewable energy is intermittent, then we would rely less on the fossil fuel. The fossil fuel are not available every time, obviously, because of the politics, because of wars, and because of COVID situations. In any situation, in many situations, the fossil fuel might not be available to each every country or each or every region. So reliance on the fossil fuel would be decreased by using the stored electrical energy. Similarly, storing during the period of low demand and using at high demand to repress the energy deficiency is also the reason that we need to store this energy. Then we have electrification of the transportation. For example, the grid systems with the latest development of the electric vehicle is required, obviously, for changing the electric vehicles in the form of or in the electric charging the electric vehicles, or in the form of batteries. So it is the batteries or the grid management is essential for the upcoming technology of electric vehicles. Also, enabling distributed energy resources, DERS, that is empowering the energy consumers, reducing the reliance on the central generation, for example, like rooftop solar panels or the batteries. This would create their less reliance on the central system, and they would be able to balance out or check the cost, and would also check the control of use of their electricity it would be up to them to how to use how they're going to use their electricity instead of depending on the governments or instead of depending on the central grids. Similarly, equity, the most important part is that fossil fuels are not available everywhere. Similarly, the hydro power is not available everywhere. Solar power might not be available in many regions. So there is there is a limit to which how much the people of different regions can get access to that particular type of energy. So the equity in energy beyond regional or climatic condition is important. So storage of energy and grid management would assist in the maintaining the equity for to get so that the people of every region, of every ethnicity, of every climate would be able to get equal amount of energy. So this is why we have to store energy. We have to develop better ways to store energy, and we have to manage the grid system. Now we have generated the electricity or energy, we have distributed the energy, and we have also stored the surplus amount of energy. But the question arises, do these renewable do not produce any greenhouse gas or cause any impact? I have already mentioned the impacts or the disadvantages of using all these types of energy. But how did the scientists measure that how much which type of non-renewable or renewable energy is creating the greenhouse gas impact, or how much it is creating carbon dioxide emission, etc.? All of this can be established by using life cycle assessment, LCA, because LCA observe and study the whole life cycle to get the knowledge on the environmental impact, resource consumption, waste production, etc. For instance, we are taking lithium-ion batteries, for example. The raw material. The majority of the raw material from the lithium-ion batteries are recovered in the form of ores, obviously, like lithium, cobalt, nickel, manganese. They are not available in their pure form in the world. So they are, for example, cobalt is mostly recovered in the form of ore, which also contain nickel or copper, and we only need cobalt. So there are some, we obviously are, we are using some ways to extract particularly only cobalt from that particular ore, using various processes, using a lot of water, using a lot of energy, producing greenhouse gas emission. We are producing carbon dioxide at which stage of the raw material purification? For example, it has been estimated that the raw aluminum production or manufacturing of raw aluminum requires obviously the processes like leaching, using acids, smelting, etc. Now it requires 2 to 3 kilograms of carbon dioxide per kg of the battery production. So it is a huge amount. So it's just a per kg of the battery production. So obviously we are producing battery for the whole world. So it would be producing a lot of carbon dioxide emissions. So it is necessary to go for the life cycle assessment. The next step is the subcomponent production, that you have gathered the raw material, you have extracted the particular metal from those raw material. Then you are going to produce the subcomponent, like I said, aluminum for the battery covering, and then you are manufacturing the battery. We are using the battery. Obviously, these resources are not producing, for example, lithium-ion battery while using is not producing greenhouse gas. But what about after its usage? What about after it goes into the dump or it goes into the waste bin? What about that? For example, this battery could be reused or could be repaired. So what are the processes that would be taken by the technicians to reuse or repair those batteries? Are those processes creating carbon dioxide? Are those processes creating sulfur dioxide or nitrogen dioxide, etc.? And then after repairing or after reusing, they are refunctionalizing the battery into their subcomponent production. Now, another big concern during the battery production is air pollution caused by the transportations. Obviously, you are getting the raw material not within the factory. You're getting the raw material from a particular place where those ores are present in the mines, in the it could be in another region. For example, lithium is only present in 2 to 3 countries. So those countries extract the lithium and then transport all over the world. So the transportation is obviously creating like according to a European Environmental Agency, that 72% of the greenhouse gas emissions are shared on the road transport. So the life cycle is of importance. So it is necessary to calculate all the steps, not just usage of those renewable resources or in those renewable resources, or the usage of these batteries or the storage devices. We need to consider each and every aspect of the production of, from the resource recovery, from the reuse, from the refunctionalization, etc. Now, when we study the LCA, that is life cycle assessment, we also consider the circular economy. Circular economy is what? We are extracting the raw material, we are making the product, we are using the product, we are dumping the product, but we are reusing, recycling the product, and the cycle would continue. According to the United States Geological Survey, Survey's Mineral Commodities Summary of 2020, 32 countries manufacture the batteries. Okay, 32. Keep in mind the 32 countries manufacture battery, but 50% of output coming from 1 or 2 countries per component. Like 32 countries are manufacturing, but only 1 or 2 countries are contributing to the raw materials, 50% of the raw material. For instance, in 2019, most of the lithium was extracted from Australia and Chile, and most of the 70% cobalt was originated from the Congo. 53% of nickel was extracted from the Indonesia and Philippines, Russia. And the graphite, more than 60% of the graphite that is used in the lithium ion batteries is produced by the China. So international issues, when pandemics occurs like COVID occurred, when wars start like Ukraine and Russia, war has started, the sanctions cause the increase in import cost or limit the raw materials. So it is necessary to implement the circular economy, which is actually the approach that aims to maximize the value and utility of the resources by keeping them in use for as long as possible. By recycling again and again. For example, we have this lithium ion battery which has been wasted. You have wasted your the lithium ion battery of your phone is dead. So you, instead of throwing it away, you need to give it to a recovery centers. I don't know if they are present in Pakistan, but they are present in Europe. They are also present in China, where the metals in the lithium-ion batteries, like lithium, like manganese, like nickel, like cobalt, and even graphite, they are extracted and they are refined again, and then they are used to produce new lithium-ion batteries. So this is the concept of circular economy, and because of the problems or availability of the resources, the problems of political problems, there are pandemic problems, and many more problems. It is essential to create the circular economy concept for the recycling and reusing of many resources, so that all of the people or each and every region enjoys the benefit of the advancement in technology. And for recycling, for that to be implemented, education is important. Educating the consumer, business, and stakeholders about importance of the battery recycling and what is the uh, benefit of the circular economy, providing information on proper disposal or collection method, and doing research on creating environmental friendly way to extract this material is a way to implement the circular economy for the goal of carbon neutrality by 2050. Now, there is another concept, trilemma of energy transformation. It involves three aspects. Now, as I already mentioned, that industry is facing challenges, obviously, because of the pandemic, because of the war. Like the war in Ukraine and Russia has put energy security in spotlight. You know what happened to the European countries? They were very, very, very extremely deficient in energy because all the gas came from a particular point, all the fossil fuel came from a particular point. So, the trilemma of energy deals with three trends or three aspects of the energy. These are energy security, which I've already discussed, the intermittency, we have unequal distribution of resources, and because of the political situations or war or pandemic, there is the energy security needs to be considered. Like reliable, we need a reliable and secure energy supply. Traditional energy like coal, oil, natural gas, they we have developed infrastructure because we have been using it since industrial revolution. So that ensured the consistent supply. But when we are going to transition to the renewable energy resources, obviously new infrastructure is needed that should maintain the consistency in the supply of the energy. Second is energy equity, that is access, a country's ability to provide universal access to affordable, fairly priced, and abundant energy for domestic and commercial use. And the third is obviously, we have been talking about it again and again, the environmental sustainability, that the transition of a country's energy system towards mitigating and avoiding potential environmental harm and climate change impact is country trying to do this? Is country creating new energy resources, keeping in mind that those energy resources should be sustainable in terms of environment and ecosystem? So these are the three aspects of the trilemma of energy transformation. And obviously, the world is trying to consider all the points, and many policies are being worked on, like many private bodies, many think tanks, many international bodies are working on developing policies, laws, regulations to take into account the legislation, commercial aspects of the renewable system. Some of the examples of the international agencies or think tanks are available on your screens. You can see that these are the think tanks. They are working to create and to collaborate with the stakeholders and sharing their policy and their studies and their research to develop new to integrate the governmental and to engage every stakeholders into the policies uh, that are made for transitioning to renewable energy resources. Furthermore, these are some of the generalized policies that are being used by the many nations and international bodies during the process of transition from the non-renewable to the renewables. Like, for example, we have renewable portfolio standards. It mandates or makes it important for the organization or a business that a certain amount of or certain percentage of electricity generation should be made from the renewable sources by this specific date. This is happening in many countries. There is also a concept, feed-in tariffs. It provides financial incentives for the renewable energy producers by guaranteeing a fixed price for the electricity they generate over a set of time. They Also, there are some governments, they are giving tax incentives and credits so that the private investors would diverge into the renewable energy projects. There are also carbon pricing, the carbon taxes or cap and trade system that I discussed in the last lecture or the session. The cost of carbon emissions and give incentives to the when they transition or they convert to the system that have low carbon emissions. Then international agreements like with Paris agreement, we have UNFCCC. They have established targets and commitments to reduce the greenhouse gas emission and to promote the renewable energy adoption on the global level. Here are some of the examples of the policies of the countries. If you are interested, you can go to the page, go to the link that I have added onto the screen. This provide you with the detailed description or detailed report of the energy policy by different countries. On screen, I have taken the screenshot of the Bangladesh, Pakistan, India, etc. And check out that if all three aspects of the trilemma of the renewable energy are included in your country of interest energy policy or not. There we have also another example that is European supergrid. It was a step taken to surpass the renewable from fossil fuel by European Union in 2020. The reports established that renewable sources generation was about 30% of the total energy, and the European Union electricity production from the fossil fuel accounted for about 37%, and they aim to convert this 38% of renewable energy generation to 55%, and they are to cut off the greenhouse gas emission or carbon dioxide gas emission by the year 2030. Now, we have discussed that some of the generalized local policies or national policies and the international policies. But what is the role of international collaboration to aid the energy transformation? So obviously, international collaboration is very, very, very important. Why? Because the international collaboration is vital for the investment and financing. For example, a country like Pakistan has not ability to invest in the production of renewable energy resources or invest in the research methods to produce renewable sources. So international collaboration with countries like Pakistan is, especially in terms of financing, is essentially important, is essential or is very important. Similarly, technology transfer is important. We being a third world country are not do not have access to many technologies. For example, the technology of hydrogen production, we do not have this. So we collaborated with China in 2021 to produce hydrogen gas. Although this project has not yet started, but they tried at least. Then capacity building. Obviously, we do not have trained personnel to transition from the renewable to non-renewable to the renewable. So we need international collaboration to train the people, to train the employees, to train students, to develop their capacity to work for the these energy transition. CPEC is an example. Obviously, Pakistan collaborating with the China. All of these are added, like they are investing in our countries for the purpose of producing energy, for the purpose of producing many projects. They're also transferring their technology. They're also capacity building. They're also training our engineers, etc. There's an example. Another example of international collaboration is Alliance Energy Transformation project of UNP. And it's actually a voluntary initiative to catalyze understanding and transformative action towards a successful implementation of the transition policies worldwide. And it would help the inclusive community-centered dialogue, like related stakeholders would join their brains, they would work together, and they would facilitate and identify and find a common ground to ensure that the energy transition is socially just and the energy transition that not or this project Desert Tech and why it failed. I will just only tell you myself because we have less time. Now, project Desert Tech was a project, a plan to power European Union from the solar power plants in the Sahara Desert. The Sahara Desert is a huge desert present in Africa, and this desert has the ability to obviously it has ample of sunlight. So they decided that they should install solar power plants in the Sahara Desert, and it should have so much energy. It have so much energy, so the power plant can even power the whole earth. So this plan actually, this project actually failed because of the lack in collaboration. We discussed that the collaboration, international collaboration, is essential. So this project failed because of the lack of collaboration. Why? Because there was political agendas, right? The cooperation, investment, a huge project obviously need investment. So because of the politics, geopolitical tensions, the investors did not provide any cooperation or investment. Furthermore, the installation of the grid station, solar cells, and photovoltaics would also need a huge amount of manpower and collaboration, but they also didn't provide this manpower or this technology to the project. So they couldn't make their dream come true. Also, a more later on, more localized solutions were involved, like batteries, production of the batteries, like production of the localized solar plants, like production of the wind. So many nations did not feel the need to collaborate to this project. And furthermore, the concerns about the land use, the disturbing the livelihood of the local people, also resulted in the failure of this project. There is another concept that obviously it would seem that building a huge amount of huge solar power plant in Sahara, which lies at the equator, is wise and would be very efficient, but reality is different. Some of the aspect that I have already discussed, that obviously the nations or the collaborators were not very serious about it. Another aspect is that in 2015 the NASA published a report, and in that report they said that disturbing the Sahara Desert would create a change in weather patterns, because the Earth is consist of delicate systems which are interlinked. So the collection of sunlight would result in cooling of the desert, obviously, eventually, which would lead to more rainfall in that area. Obviously, the land would cool down because we are capturing all the sunlight, which would cool down the area, which would result in the formation of the rain in that area. And then with the passage of time, this rain would create obviously plants to grow in that area. It might create a forest. Now, according to the NASA report, the Amazon forest is fertilized from the Sahara sand, which is very has many nutrients in it, and the Sahara sand actually blows over the Atlantic Ocean over the long distance. So during its transfer, it also creates algal blooms over the areas, which gives out oxygen that we need to breathe. And the heat pattern at one place regulates the rain and wind pattern, and the other place as well, creating different weather and climatic condition. So forest in the huge area, that is, for example, with the passage of time, a forest might develop in the Sahara, would be an extra one. It would create it would also, okay, now obviously it would change different weather and climatic pattern that would obviously disturb them. Another thing is that the forest, wherever forests are present, the air is very damp. It collects, obviously, because of the transpiration, water vapors, and water vapor itself is a greenhouse gas. So an extra forest would obviously result in a more formation of water vapors, which would ultimately makes the earth get more and more warmer. So a lot of resources, a lot of research, and lot of aspects need to be studied for the project to start. And we have only 10 minutes remaining, so I will conclude our session here. If you have any question you need to ask, please feel free to ask. I will also share all the resources and the research paper along with the presentation today in the group. So if there are any question, you can ask me now.
हेलो।
Hello.
जी, मैं मैडम अगर ये लेक्चर यानी वीडियो उसमें जिस तरह पहला क्लास आप लोगों ने अपलोड किया था, अगर उस तरह हो जाए तो हमारे लिए
जी
थोड़ा
जी, ये
बेहतर हो
होगा,
जाएगा।
ये होगा, ये अपलोड भी होगा, आपके साथ स्लाइड्स भी शेयर होंगी, बल्कि इन स्लाइड्स को जिस मटेरियल से बनाया है वो पेपर्स भी मैं ग्रुप में शेयर करूंगी, सब कुछ होगा।
सही है, क्योंकि अभी 50% तो हमने तो यानी वो गेन किया, लेकिन जब हम दोबारा सुनेंगे और वो करेंगे तो थोड़ा और
जी जी,
इजाफा हो जाएगा
मैं
इसमें।
हाँ जी, मैं समझ सकती हूँ। आई माई सेल्फ इज अ स्टूडेंट, मैं पीएचडी कर रही हूँ, स्टूडेंट हूँ, तो होता है कि आपको बाद में चाहिए होती हैं लेक्चर्स समझने के लिए दोबारा। आप इसके लिए परेशान ना हो, ये यूट्यूब पे अपलोड हो जाएगा।
ओके, थैंक यू।
ओके, I think that's it. It was wonderful having a session with you. Allah Hafiz.
अल्लाह